theory of general relativity and how it relates to gravity.
Well, I'll be glad to. Let me start earlier in 1905 when I published my Theory of Special Relativity. In this theory, I showed that space and time are connected in a concept called the space-time continuum. You can model this space-time in two dimensions. That's what you see, this fabric here, right here. I call this theory as special relativity because it only applies for the special case when the objects are moving at constant speed and if space-time is flat and not curved.
So you are saying that space and time is like this fabric you are showing here?
Well, yes and no. You see, this fabric is an approximation in two-dimensional. Space and time is actually four-dimensional. You have the three dimensions of space, which is length, breadth, and height, and one dimension of time.
Okay, so is there other cases beyond this special case of constant speed and flat space-time?
Indeed, there are many. So it culminated in me coming up with the general theory of relativity in 1915. So this is where I finally managed to describe what gravity is.
Okay, tell us!
So in this theory of general relativity, massive objects can actually cause a distortion in the space-time fabric. Let me show you. If I were to place this object in this fabric, what do you see?
I can see a dent in this fabric.
Now, let's put in a bigger and more massive metal ball. What do you see?
The dent is deeper.
Now, let's put two of these metal objects. You can see that it caused a bigger dent. So, massive object cause a dent in space-time fabric. The more massive the object is, the bigger and deeper the dent is. This is what is explained as one of the consequences of my theory of general relativity.
Okay, so massive objects cause dents in space-time fabric? But what has this denting got to do with gravity?
Well, that is what we will explain in our next video.
Okay, before we go to the next video to understand how this bending of space-time relates to gravity, let's understand a little bit more about the bending itself. What we see as the bending of space-time using the metal balls is just an approximation in two dimensions. We can show it in four dimensions though, as it is not easy to simulate the time factor visually. So, the next best thing we can do is to show an approximation in three dimensions of space-time. This visualization will show you the bending in three dimensions. I hope that it helps you to visualize the bending. Thank you for watching, and please look out for the next video that explains how this bending relates to gravity. Please like, share and subscribe to our channel and click the bell so you will not miss our upcoming videos. Thank you.